Hey, this is Ken Davis with Performance Air Conditioning, and just a couple of days ago, I had a customer ask me to look at his house, and very common complaint. He has two rooms that are much warmer than the rest of the house, and wanted to see if we could come up with a plan to address that. And we've kind of developed an approach that looks at this more from the building science perspective and allows us to kind of hit that a little bit more exactly than just throwing in some bigger duct work and potentially actually making the problem much worse. And so, where I like to start with this is step one. Before you think about changing any ducts, we want to look and make sure that we have no zonal pressure issues, meaning that we don't have a room that's either going negative or positive in pressure, which can create you know, a big problem with, trying to cool that space. And oftentimes we'll see, maybe there's too much return duct and the space is going negative and it's actually sucking in, hot outside air or hot air from the attic, depending on how well the house is sealed, right into that room, or potentially going positive and actually pushing some of the air out of the room. So before we go any further, just we use a precision digital manometer. I like the one from TEC or the Energy Conservatory, the DG8, but Retrotech makes some good ones, and I'm sure there's others on the market. Those are the two that I'm familiar with. And just make sure that basically have the HVAC system running. Put a hose on one side of the door, we stand on the other with the HVAC system running, and of course those pressures are equal when the doors are open, and then close them and just make sure that they stay within 3 pascals. If we have a situation where they're not staying within 3 pascals, then we look at some kind of a pressure relief, either some transfer grills or jumper ducts that would help balance that pressure out. Personally, I don't feel like you should ever try to do a duct change without addressing those zonal pressure abnormalities first. The second thing I like to do is come in and record airflows out of each vent. We use one that we got through Retrotech. They don't actually make it, but it's powered flow hood. It's very, very precise and accurately measures airflow coming out of the registers in those vents. And I just take that and record it. And then the third step is I'll perform a manual J of the house. Now, since we're looking at existing structures in this case, I really like software that's called Conduit Tech. And the way Conduit works is, you could either use an iPad or an iPhone. Really, it's kind of designed for the iPad, and these come with LiDAR scanners built in, and there's some specifications you have to have on the iPad you purchase. And we use that LiDAR scanner to basically scan the room, enter some information about insulation and windows, etc. And the software will actually produce you a manual J calculation fairly quickly and gives you some nice 3D renditions of the house. So when you're discussing this with a customer, you can spin the house around on the screen, kind of look at this, and get some pretty good information and just kind of discuss the plan. After that, I'll go and measure, total system airflow. I use the TrueFlow grid to do that because I feel it gives me some pretty accurate numbers. MeasureQuick, for those that are MeasureQuick users, and we are big MeasureQuick fans, will give you some estimated airflows as well, which I found to actually be extremely accurate. Probably not quite as accurate as the TrueFlow grid, but certainly can get you very close. Part of our assessment of these situations anyways is doing a good MeasureQuick assessment, getting a good score on the house. If you've never used MeasureQuick before, I would highly encourage you to go check out the software. It's actually free to start. You don't have to pay for anything until you start doing some of the more advanced reporting, but you can get comfortable with it, and that's one of the really good ways of seeing how a system's performing. Once you get that, you got the manual J calculation, and you have a desired BTU for cooling this house. But as most of you know, oftentimes what's in a house versus what the manual J calculation is oftentimes very different. And in this house it was quite different. He had 4 tons or 48,000 BTUs of air conditioning, and the manual J actually called for 3 tons worth of air conditioning, or 36,000 BTUs. And so what I'll do is I'll just kind of mathematically ratio that up. So in this case, 36,000 will go into 48,000 1.33 times, and I'll just record that number. since I already have a manual J calculation and we do a room by room calculation, we know the desired, CFMs in that room, or we know the load in that room. We can divide that out using the previous information that we've obtained and get the desired CFM in that room. Now, if you use that number by itself, you'll be inaccurate, because remember, like in this case, the total air conditioning system was a full ton larger than the manual J calculation. So you multiply that desired number times that ratio number, or the 1.33, and that gives you your new desired CFM. Once you have that number, then you can calculate out and make any corrections to the ductwork that you need in order for you to achieve those numbers. And of course, you want to put in some dampers in there, some hand adjustable dampers in there. And once you get that, you can run the system and have one person adjust the damper while the other is measuring, with the powered flow hood until you get that exact number. The advantage of this approach is really it's kind of taking the guesswork out of it, right? You know that you need to achieve a certain airflow in this room in order to get the desired results and kind of balance that room out. And so rather than just, guess and go, okay, well, I'm going to throw in X size duct and hopefully that makes it better and we don't overdo it, we're actually able to kind of, dial this in a little closer. And I know this is a real common problem that, HVAC techs face on a regular basis. And I think a lot of organizations kind of struggle with this in order to find out really an exact solution. In the case I was previous discussing, they actually had another company come out and they reducted the house and really didn't resolve the issue at all. So, this is just a pretty good solid approach, a way of doing it, and hope this was informative.